Complementary events. So we talked about that very briefly in the last example, with this example up here. So the previous example showed us a case where two events were complementary. In other words, either happens or doesn't happen. So yellow or not yellow. There was no other option there. The marble was either going to be yellow or not yellow. The two events cover every possibility, and they're mutually exclusive. You can't pick out a marble that is both yellow and not yellow. So in that situation, it was always going to be the case that the probability of yellow add the probability of not yellow is 1. Yeah, it's absolutely certain that we're going to get that situation, either a yellow or not a yellow. So when we have this type of situation where there's no overlap between the events and they fill all the possibilities that there are, then one event is A and we call its complement not A. So you get an even number or you get an odd number. Odd is the complement of even. So you could think of that odd as being not even. And whenever that's the situation, you add the two probabilities and you're going to get 1 because it's certain that one of them happens. So Bernie's got his 10-sided die again, numbered 1 to 10. Determine the probability that when the die is rolled once, he obtains a multiple of 4. So 4 and 8 are those. So the probability multiple of 4 is going to be 2 over 10, which is 1/5. He gets a number that's not a multiple of 4. Now, we could do 1 take away a fifth using our complement, and that's 4/5, but let's think about it. Let's write down the ones that aren't 4 multiples of 4. 1, 2, 3, 5, 6, 7, 9 and 10. 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 10, which is 4/5. So we've got the same answer here as when we considered the complementary events, and that lends credence to what we've been saying.